another lecture of the subject control system. In previous lecture I discussed about final value theorem and initial value theorem, where we learned how to use those theorem and where when those theorems are applicable or valid, what are the conditions, what you need to check to apply those theorems first. And those theorem, initial value theorem was giving you the initial value of the time domain function from the frequency domain function, and final value theorem was giving you the final value of the time domain function, that means the value when t tends to infinity, and it was giving you from the frequency domain itself. You don't need to convert it, I mean Laplace domain, not frequency domain. Often frequency domain, Laplace domain is referred to as frequency domain, but it's not actually frequency domain, we call it Laplace domain. But sometimes if we call it frequency domain, it is not wrong statement, but we should not, because we have in frequency domain we have Fourier transform for that, and to distinguish this we call it Fourier transform, we call it frequency domain, and Laplace transform we call it Laplace domain or S domain. But it also gives us the frequency information only, that's why we often call it frequency domain. And whenever you are not using Fourier transform in your course, you can call Laplace transform as not Fourier transform, I mean Laplace domain as frequency domain, because we are not jumbling up those two terms, frequency domain and Laplace domain, in two different things, Fourier transform and Laplace transform. Okay, so final value theorem was giving you the function, the value of the time domain function at t tends to infinity from the frequency domain expression. And sometimes it was valid, sometimes it was not. When it is not valid, when final value and initial value theorem is not valid, then you need to convert the frequency domain expression or the S domain expression into time domain function, its corresponding time domain function. Again, if if the function is like that, the initial value and final value theorem is valid, but the initial value and final value, those two values, any one of those two values are not asked. They are asking any value at time t equals to any value 0 to, I mean in between 0 to infinity. So in those cases you need to apply, you need to actually convert those Laplace domain function into time domain function, then you need to put the value of t, and then you need to calculate the value of the function. So for that we need inverse Laplace transform. Inverse Laplace transform. Okay, how we can obtain inverse Laplace transform? As we had an integral formula for Laplace transform, it was, let me write down here, it was to find capital F of S from Ft, we needed to compute this integral. So 0 minus 2, this was my function. To compute Fourier, to compute frequency domain, I mean S domain function corresponding to this time domain function. Now I have this Fs in my hand, now I want to get this time domain function. Now there is another formula, the formula is like this, Ft, or it is also written as Laplace in L inverse of Fs, that means L of Ft is Laplace transform of Ft, and L inverse of Fs is inverse Laplace transform of Fs. Now the formula is 1 by 2 pi j integration sigma minus j infinity to sigma plus j infinity f of s e to the st ds. This is the formula. Now the significant difference is you had Ft, and then you are transforming that time domain function into frequency domain, so the integration was with respect to t. Now you have Fs and you are converting this S domain function into time domain function, that's why your integration is with respect to S. And one thing to remember, whenever in Laplace transform it is e to the power minus st, but in case of inverse Laplace transform, it is e to the power plus st. 1 by 2 pi j term is there, and another one thing is the basically limit of the integration. Now the limit of the integration is this, because in time domain t was at any instant t holds some single number. So t actually represented by t was represented by some axis, we call it time axis. So time axis, and we are considering the function frequency domain, the time domain function. We were taking the time domain function information from t equals to 0 towards t equal to infinity. That means the time axis 0 to infinity was converted into some frequency domain. Now in case of frequency, if you have simple omega, or in case of let's say Fourier transform, you have j omega. So j omega at any instant of time, it may be the total thing is imaginary, but this omega holds some real number. Omega holds some real number, that means it also can be represented through some axis j omega like this. Now in case of S, instead of j omega we have some sigma plus j omega. That means one real term and one imaginary term. Is actually a complex number. Now as I said, we have frequency domain information in Fs. I mean frequency information content in Ft is represented by Fs. So how it is represented? Look, the time from 0 onwards, we converted those time axes into some frequency domain, S domain, and that S domain is some sigma plus j omega. Now sigma can be plotted over one axis and j omega can be plotted over another axis. This was we called something S domain or S plane. We call it S plane. It is a complex plane. As t is real, the real number line would do that work to make it axis, but in complex case we don't have lines, we have complex plane. So it is S plane. Now at any instant of sigma, we can vary omega from minus infinity, here it is from minus infinity j infinity to plus j infinity. Now this omega information is my frequency information, and this Fs is giving me the frequency information. That is why this omega term is varied in case of the integral. Sigma is kept constant, and minus j infinity to j infinity, this total line for any sigma, let's say for sigma value this total line is converted to time domain, converted to time axis, or this total line, let's say sigma value is this total line is converted to basically time domain, time axis. So based on different sigma, different frequency information you have. Okay, now I am sweating because of this temperature, excuse me. Now this frequency information we need to convert into time axis. So actually in case of Fourier transform, what we do is instead of sigma plus j omega, we just convert it into j omega. So one time axis is converted into one frequency axis, but in case of Laplace transform we convert it into frequency axis is there, but different sigma has different frequency components. Okay, based on this sigma, now if you go deep into mathematics, then you will know what does this sigma signify. But actually this much details we don't need, we just need to know the formula. Again this formula we will not use, just like in Laplace transform case we didn't use this formula. Again in inverse Laplace case we will not use this formula again too much, or even once we will not use. So what we are going to do is, we have some standard function just like in Laplace transform, like impulse function. Impulse function is having Laplace transform 1, ut, that means step function, is having 1 by s, rt is having 1 by s square, t to the power n ut is having n factorial by s to the power n plus 1, e to the power at ut, or e to the power plus minus at ut is having 1 by s minus plus a. Again, sine omega t ut is having omega by s square. Just to remind you, and cos omega t ut is having s by s square plus omega square. This was the standard function which we will need, okay, which we need in future. And now, if the frequency domain function, that means fs, can be converted into, or can be converted into some linear combinations or some summation or something like that between this kind of, I will give you what I am going to say, what I am trying to say, I will give you example. But if we can represent my fs in terms of this standard function, then I can find the time domain information. That is what I am trying to say. Okay, this is not equal, this is converted into. Okay, now then let us take some example. We will not use this formula, rather what we will do, we will just see whether we can use the standard function or not. So let us take one example, maybe s by s square plus 4s plus 29. This is fs, and we need to compute ft. How are we going to do? Look, this function is not some standard function, so we need to first convert it so that it looks like standard function. So okay, let me erase this one, because I think as we don't need this one, I think I don't need to keep it here. So I'm erasing, maybe I'm erasing the heading as well, because we know we are discussing inverse Laplace transform, so there's nothing to written as a heading. So let me write the function here so that I can do it clearly in the board. 29. Okay. Now let's see, the function can be written as s by s square plus 4s plus 4 plus 25. Just 29 is divided into 4 plus 25. Now s by s plus 2 whole square. This is s plus 2 whole square. Now this is 25, means 5 square. Now remember, for cos omega t, my function was s by s square plus omega square. Now it is pretty much same, rather s is there, omega square, omega value, if omega value is 5, then it is okay totally. But the thing is, instead of s square, here I have s plus 2 whole square. Now remember one more thing, I had a property of the Laplace transform, that is frequency shifting. ft is giving you fs, then e to the power minus ft will give you f of s plus a. This was the formula, this was the property. Now look at this, if I write it as cos of 5t, then it will give me s by s square plus 25. But we have s plus 2 whole square plus 25. Now I am going to write e to the power minus 2t cos of 5t. So it is becoming s plus 2 by s plus 2 whole square plus 25. Now the denominator is coming as same, but the problem is in numerator. But that is not a big issue because we can always do s plus 2 minus 2. Now we can separate. So what I am going to do, I am erasing this one. You know how I am getting. Now just writing it separately, s plus 2 whole square plus 5 square, let me write is 25, minus 2 s plus 2 whole square plus 25. I have two sub functions. Okay. Yeah. Now I need to convert this one. So how I am going to do this? Let us consider sine 5t ut. Obviously, if there was if I was written like I sorry, I had written cos 5t, but that would have been cos 5t ut. Just remember that ut is there because we are considering for t equals to 0 to infinity, not before t equals to 0. So if even I am not writing ut everywhere, just consider that it is there. Okay. As of now, as I can remember right now, so I am writing it. Now, yeah, the thing is, for this you are having omega by s square plus omega square, right? So it is 5 by s square plus 25. Now do the same thing, e to the power minus 2t sine 5t ut will give you 5. Wherever there is s, replace it by s plus 2, s plus 2 whole square plus 25. Now it is pretty much same, so I can write it as, instead of 2 by s plus 2 whole square plus 25, I need 5 by, so I can write 5, sorry, I mean 2 by 5 like this. This is clear? So this term is giving me e to the power plus e to the power minus 2t cos of 5t ut, minus this term is giving me, look, this term is giving me this one, and this term, if we have fs, if we have ft to compute fs, now if we have aft, we will get afs. Similarly backward, fs, ft, afs, aft. That means this term is converted into this and this term is multiplied with that. So let me write it, 2 by 5, let me change the pen, 2 by 5 e to the power minus 2t sine of 5t. Now this is the time domain function of time domain representation of this one. Okay. Now again, I always I do this wrong thing every time. I use equal sign, but it is not equal. If it is equal, then you need to write it ft. Okay. I sometimes write like this, ut means 1 by s like this, but it is not actually the case. The case is, it implies that the Laplace transform is 1 by s. Okay, just remember that. Okay, so this is the formula. I mean, this is the time domain representation of that frequency domain function. Now how I am going to do this? Just by experience, I can, you need to have experience with that. If you solve more number of problems, then you will get experience, sufficient experience to just write it within 2 steps, like from here to direct here and to direct here. You don't need to compute, okay, this is going to be this is going to be done, then this is going to be done. Not all these things. Just looking at the function, you can do this with some 2 or 3 steps. Okay, and how you are going to convert that into standard form function, that needs some experience. I hope it is clear. Now if I have another function, let's say the same thing, I have another function which is like this. It is given as summation of multiplication of 2 terms. Like, can you remember the pole 0 form? It is like that, s plus 2, s plus 3, let's say. Now what I am going to do, I am going to multiply this equation, s square plus 5s plus 6, and then I am going to convert this portion into 2 square term, summation of 2 square terms. Okay, 1 by s square plus 2 into 5 by 2 s plus 25 by 4 plus 6 is there, minus 25 by 4, because 25 by 4 is taken extra. So this is going to give me s plus 5 by 2 whole square plus 6 minus 25 by 4. What is 6 minus 25 by 4? It is minus 1 by 4. Okay, so it is minus 1 by 4. Now the problem here is minus 1 by 4 cannot be written as square term. Like, you can write it as minus half square, but that is not the formula. The formula is something plus, and you have right now like this. Now if you are trying to write this in terms of some square term, you are getting I by 2 or j by 2. Let me call it j by 2 whole square. J by 2 whole square will give you minus 1 by 4, but this is what? Omega square, and omega is frequency. Frequency cannot be imaginary. The frequency was in imaginary axis, but the frequency was multiplied with some imaginary term, and then it was giving you the imaginary axis. Not frequency is not itself imaginary. So here the problem is like that. Now, is this happening because of 2 and 3 only, or if there is anything in this form can lead to this problem? What do you think? Is this for only 2 and 3? Let me check for 4 and 5 whether it is giving or not, or let's say 1 and 9, 2 and 15. We cannot check everything. So we are going to do one thing. Let me call it A, let me call it B. Now we will check whether for any A and B this is going to like that or not. Then we will come to certain conclusion. Okay, now 1 by s plus A, s plus B. So the problem is within the denominator. So let me consider only the denominator. So it is s plus A. Let me just remove this one because we don't need those values. S plus A into s plus B. This is my denominator. So it is giving me as s square plus A plus B into s plus AB. Now what I am going to do is I am trying to make it some summation of some square terms. S square plus 2 into A plus B over 2 s plus A plus B whole squared by 4 plus AB, which is already there, and this is taken extra, so this must be negated. Okay. Now this portion is giving me s plus A plus B by 2 whole square plus AB minus A plus B whole square by 4. Now to make it a square term, it must be greater than 0, otherwise the omega will be imaginary. So this must be greater than 0, this portion it must be greater than 0. Let me consider that one. AB must be greater than 0. That means AB must be greater than this term, a plus b whole square by 4. That means 4AB must be greater than a plus b whole square. Or you can write it as 0 must be greater than a plus b whole square minus 4AB. Or you can write this like this, a plus b whole square minus 4AB. A plus b whole square minus 4AB should be less than 0. Now what is a plus b whole square minus 4AB? What is a plus b whole square minus 4AB? A square plus 2AB plus b square minus 4AB is a square minus 2AB plus b square. So it is a minus b whole square. So from this conclusion I can write as a minus b whole square must be less than 0. So if the thing is given like this, summation or product of some two different poles, then my condition to make it summation of some square terms, two square terms, my condition is a minus b whole square must be less than 0. Now think about it. If a is real, b is real, can a minus b real? Can a minus b whole square be less than 0? If a is real, b is real, a minus b is always real. So a minus b whole square is always greater than 0. So if you have this type of problem, you cannot ever solve this using this type. So now what we are going to do then? How we are going to convert this? Now we have a technique called partial fraction. What is partial fraction? Partial fraction means you have a function which is in terms of some fraction, then that function is represented in terms of sum of some different fractions, and that fractions will be individually a standard functions. I hope it is clear. So I can write it, let me remove AB, let me do it using 2 and 3. I can write it as sum of two different fractions, a by s2 one fractions, a by s plus 2, and b by s plus 3 is another fraction. Now if a is constant, a is obviously constant, so a is obviously constant, so it will be giving you a e to the power minus 2t ut, and what will it give? It will give b e to the power minus 3t ut. So the total thing will be pretty easy. So my objective is here, we can write this as this, but my objective is here to find the value of a and the value of b. How we are going to find the value of a and value of b? Let me do it. Okay, this function can be written as s square, okay, s plus 2, s plus 3, and then a into s plus 3 plus b into s plus 2. Now as plus 3a plus bs plus 2b, or let me write taking common s terms. Okay, so s into a plus b plus 3a plus 2b is s plus 2, s plus 3. Now what is the next thing we are going to do? We are comparing these two functions. The denominator is okay and it should be okay. So the numerator is 1. So I can write as s into a plus b plus 3a plus 2b to b equals to 1. Now this 1 is s into 0 plus 1, 0 into s, because so now compare the coefficient of s square, I mean s to the power 0, s square, like this. So 3a plus 2b is of course 1, and coefficient of s is a plus b, which is 0, a plus b is 0. So a equals to minus b. Okay, that's great. Now I am going to replace this 3a, that means we are just solving these simultaneous equations. 3a is equals to minus b, so minus 2a will be equals to 1, so a equals to 1, and as a equals to minus b, b equals to 1. So the function can be written as 1 by s plus 2, a equals to 1, sorry, b equals to minus 1, minus 1 by s plus 3, putting this value here. Now let us verify we are getting this or not. We are getting this or not. Let us verify. S plus 2, s plus 3, s plus 3 minus s minus 2, s gets cancelled, 3 minus 2 is 1, and yeah, we are getting it, just this function. So now we have the value of a, value of b, or this. Now from this equation I can convert it into time domain function, which is e to the power minus 2t ut minus e to the power minus 3t ut. So the time domain function of this fs is this, so the ft will be e to the minus 2t minus e to the minus 3t into ut. This is the answer. So partial fraction is something very useful in terms of converting, actually in terms of inverse Laplace transform, and it is useful for one more thing, like now if it is given in this form, then you cannot actually convert that into some summation of some square terms. Now if it is given you in a square plus 5s plus 6 form, then you will might think first it can be converted, I guess. So every time you got a question, if it is in this form, then don't worry, just use partial fraction, and if it is not in this term, rather if it is in this format, just try to think that whether using middle term factor this thing, I mean this separation can be, this factorization can be done or not. Let's say okay, 3 2s are 6 and 3 plus 2 is 5, so it can be done easily. Then you can find it this expression, and from this expression you can expand it into partial fractions. Now one more thing is, whenever you are using sine formula or cos formula, then what you need to do is you are only confined into second order. That means square must be there. If it is not square, instead of square, if it is to the power 3, or I mean if it is cubed or to the power 4, then those things will not be valid. So in this case, let's say there is another term s plus 1 multiplied here. So partial fraction is some important tool to convert this if it is of any order. It is easier, and can be done. Now mainly two things you must need to know is, whenever, now is there any shortcut, like this is a pretty long process? Look, this is not a pretty long process, it is looking as long because we are just I am just doing the whole thing with explanation. You will just calculate it in mind, so it will not take much time. But one more thing is, if I have 1 by s plus 2, or let us say fs is some function, some ns by ds, and ds I am writing it as s plus a, s plus b, s plus c, etc. So now how you are going to do this? Look, you are going to convert it into a by s plus a, plus b by s plus b, plus c by s plus c, okay, plus dot dot dot. Now how we are going to convert calculate a? There is a formula, that is just look at this term, okay. This is strictly valid if the powers are 1. If the power is 2, then there is another, I will discuss that one, okay. Now you can find the value of capital A using this formula. A will be limit s tends to minus a, small a. We will put this value, limit s tends to minus a, s plus a into fs. So what it going to do, what is this going to do is, it will put the value s equals to minus a, that means it will equate it to 0 and it will get s equals to minus a, and that value will be put in this function, but before that you need to multiply it with s minus a, because otherwise if it is s equals to minus a and you put this on fs, then it will be 0. So something by 0 will be infinity. So you must need to cancel this term by multiplying this in the numerator like this. Now you put a and then you calculate the value of a, and similarly b, for b it will be s tends to b, for b s tends to b, s plus b fs. It's pretty simple. Like we had s plus 2 plus b s plus 3. Now I'm going to find a. What is a? A is limit s tends to, what is a over? A is over 2, I mean s plus 2. So s plus 2 means s to the power minus, s tends to minus 2. S tends to minus 2, s plus 2 into fs. So s plus 2 is this, and fs is 1 by s plus 2, s plus 3. So s plus 2 get cancelled, and you are left with s tends to minus 2, 1 by s plus 3. Now put s tends to minus 2, s equals to minus 2 plus 3, that is 1, and we got a value as 1. Similarly for b, limit s tends to minus 3, s plus 3 fs, that is giving you as, I am not writing it again, 1 by s plus 2 only, then you put s equals to minus 3, 1 by minus 3 plus 2 equals to minus 1. So the partial fraction expansion is like this, 1 by s plus 2 minus 1 by s plus 3. Simple. So this is the case. Partial fraction expansion for non-repetitive pole. However, we can call it non-repetitive pole. If s equals to minus 2 pole is repetitive, that means if it is 2 times, then it is squared. If it is 4 times, it is to the power 4. But non-repetitive means it only appears 1 time in the complex plane. That means minus 2 is only having 1 pole, not more than 1. Then you can use this formula. Now if there is 2 poles, the same function, but 1 pole will be repetitive. Now how we are going to do that? Let us say fs equals to 1 by s plus 2 whole square, s plus 3. Now s equals to minus 2 pole, is appearing twice and 3 is appearing once only. Now, those poles which are appearing twice must be written twice, a by s plus 2 once and b by s plus 2 whole square once, and another will be s plus 3. Function, the expansion will not be only b by s plus 2 whole square plus c by s plus 3 whole square. Then there will be some problem. What kind of problem? There will be b will be something else, like, okay, let me check if we can do this. Okay, let me show you the problem. B by s plus 2 whole square plus c by s plus 3. Now the problem is, you are going to expand it like this, s 2 whole square, s plus 3. Now b into s plus 2, that means b s plus 3, c into s plus 2 whole square, that means bs plus 3b plus cs square plus 2cs plus 4 by this portion. I am not writing it again. So c, taking common s, it is giving you b plus 2c plus 3b plus 4 by this portion. Now the numerator is 1 only, so this term will be equals to 1, 3b plus 4 will be equals to 1, b equals to minus 4 by 3. I have got it. Now c equals to 0. Oops, yeah, c equals to a square. Now a square, coefficient of a square is 0 here, so c equals to 0. Now again, coefficient of s is also 0, so b plus 2c is equals to 0, b plus 2c equals to 0. Now if c equals to 0, b equals to also 0. Now this is the contradiction. That means what? That means you cannot convert this into this portion, into summation of these two. You need another term. Like here, what is happening here is the total order is here 3. The total order is 3. So ultimately the total order of this expression will be the total order is 3. Ultimately the total order in this expression will be 2. Why? Because in this case s plus 3 will be multiplied with c, and in this case s plus 2 whole square will be multiplied, sorry, in this case s plus 3 will be multiplied with b, in this case s plus 2 whole square will be multiplied with c. So s plus 3 is multiplied with b, that means order 1, c is multiplied with s plus 2 whole square, that means order 2. So the highest power will be 2. Highest power will be 2. Now highest power 2 means you have 3 things: s equals to 0, s equals to 1, s equals to 2. Highest power is 2, so s equals to 0, s equals to 1, s equals to 2. But you have variable only 2 things, you have unknown only 2 things, c and b. So it might happen that some contradiction arises. These 3 coefficients, coefficient of s to the power 0, coefficient of s to the power 1 and coefficient of s to the power 2 will be there. So these 3 coefficients will be giving you 3 equations and with only 2 variables. It often happen that this 3 equation will not be simultaneously, cannot be simultaneously solved like this. If c equals to 0, so b equals to 0. If c not equals to 0, then there will be some term s square, or there will be some coefficient of s square, but there is not a term. Now what we can call b plus 2c, let us say not equals to 0, b is minus 4 by 3, c equals to 0. But then what will happen? B plus 2c, there will be some term, some coefficient of s, but that is not the case. There is no coefficient of s. So all these 3 equations must be satisfied, and so for that we need another variable. That's why we call it as a by s plus 3. Now if you can calculate this one, then it will be happening correctly. Let us compute, sorry, s plus 2, s plus 2 whole square. The LCM will be s plus 2 whole square plus s plus 3 into s plus 3. So s plus 2 is gone, so a into s plus 2 into s plus 3 plus b into s plus 3 only and c into s plus 2 whole square. Now this is there, a square plus 5as plus 6a plus bs plus 3b plus c square plus 2, yeah, 2cs plus 4c. Now take common a square terms, a plus c, a plus c is equals to 0, so equals to minus c. One thing I have got. Now another equation, equating coefficient of s as 5a plus b plus 2c to be equals to 0. Okay, now a equals to minus c, so I can write here minus c, that means minus 5c plus b plus 2c equals to 0. That means b minus 3c equals to 0, that means b equals to 3c. Another equation is coefficient of s to the power 0, that means 1 here. So here it is 6a plus 3b plus 4c, it is to be 1. Now b equals to 3c, b equal to 3c, so 3b equals to 9c plus 4c plus a equals to minus c, so 6a equals to minus 6c. So this is equals to 1. So now I can calculate c value. 4c minus 6c is minus 2c, 9c minus 2c is 7c equals to 1, c equals to 1 by 7. C equals to 1 by 7, that means a equals to minus 1 by 7. A equals to minus 1 by 7, c equals to 1 by 7, b equals to 3 by 7. Now you can put this into this equation and you can verify that function. Now as you have this value of a, b and c, now I can put it here minus 1 by 7. So it is minus 1 by 7 s plus 2 plus b is 3 by 7, 3 by 7 s plus 2 whole square plus c is 1 by 7, 1 by 7 s plus 3. Now this is standard function, we have no problem with this. Minus 1 by 7, 1 by s plus 2 is 1 by s is ut, 1 by s plus 2 is e to the minus 2t ut plus 3 by 7, 1 by s plus 1 by s square is t ut, 1 by s plus 2 is e to the power minus 2t t ut. I hope you have got it. T ut means RT. RT is 1 by s square. So T ut is 1 by s square. And if you call it e to the minus 2t ut, then s will be replaced by 1 by s plus 2 whole square. S will be replaced by s plus 2. 3 by 7 will be there. Now 1 by 7 e to the power minus 3t ut. Now you can just simply, just to look beautiful, okay. 1 by 7 taking common, e to the power 3 minus 3t plus e to the power minus 2t taking common from these two, one is t, another one is ut, I mean minus 1. Now for t it is 3t minus 1. So this is my ft. So using partial fraction expansion, I can easily find out my time domain function. Okay. Now, so mainly in questions, these two types of equations are there. These two types of questions are there. One is with twice repetitive pole, one is no repetitive pole. For no repetitive pole, you don't need to repeatedly write this one, only one term will be there. Okay. For twice repetitively pole, though that pole which is written repetitively, that will be written in the expansion repetitively, once with no power and once with the power given in the question. Now if it is 3, then the expression, numerator expression using a, b and c will be of order 2. Order 2 means, no, order 3, because it is 3 and it is 1. So the numerator expression in this case ABC, using ABC, will be of order 3. 4 minus 1, 3. So for that you have s to the power 0, s to the power 1, s square and s cube. So you have 5 things. So you need to then find A, B, C, D. How are you going to do? This thing will be square, this thing will be cubed, and okay, let me just write it clearly in order to make you understand easily. Okay, so whenever it is s plus a, s plus b, then you can convert it a by s plus a, it is equal b by s plus b. Now if it is a plus a whole square into s plus b, then you need to convert it like this: a by s plus a, b by s plus a whole square, because it is squared, c by s plus b. Now if it is, instead of 2 it is 3, both true for which one will be there? If it is square, if it is squared, then 2 times will be written, once with without square, once with square. So if it is to the power 3, then it will be written once without any power, once with a square, once with cube, because, and you will stop there with cube, and then the second term, not C, here it will be D. Like this you need to expand the partial fraction, and then just easily you can, comparing the coefficient of s to the power 0, s to the power 1, you can find the value of a, b and c, a, b, c, d, how many terms there, that is not the problem. Thus you can calculate the, and again if instead of 1, if it is s plus a or s plus b like this, if instead of 1 it is, let's say, s plus c, then that is not a big problem. You can just calculate that, and to, while equating, you don't need to a to the a into s plus c, no. While equating a, let's say a, let's say for example a plus b s square plus 3a plus 4b s, then what you are going to do, let's say 6a plus 3b, what you are going to do is, while taking the common of coefficient, you need to be careful. Every time whenever it was only 1 there, 1 was there in numerator, then we were considering this to be 0, this to be 0, this to be 1. Now the thing, the numerator is changed to s plus c, so we will consider this to be 0 because there is no s square term, but s term is there, the coefficient of s is 1, so it will be considered as 1, and c, it will be considered as c. Like this you can easily find any partial fraction from any function, and then you can obtain the time domain function. So this is inverse Laplace transform. The more problem you solve on your own, the more experience you will gain, and the more confident you will be in case of expanding partial fraction or converting or representing the function, given function into some convenient way, a convenient function. It will be dependent on the practice. Okay, and I will not take so much more example. I will not take no more example. I will just go towards the next chapter. I will, if I think it is needed, I will make some separate video lectures. As I said, always I'll make some separate video lecture series where I will solve some numerical questions, but here I will take no more numerical questions. Okay, so this much for today's lecture. From next onwards, we will be starting time domain analysis, and it is very interesting. We will see how it all goes. Thank you for this. Thank you for watching. This much for today's lecture.